December 1944, Hürtgen Forest, Germany. American tank crews unveiled their answer to German fortifications. A Sherman tank, with 144 rocket tubes welded on top. Every Wehrmacht officer who saw it through binoculars thought it was a mistake. It was not. The M4 Calliope would deliver more explosive tonnage in 90 seconds than a 12-gun artillery battery could fire in 10 minutes, and would force German commanders to abandon defensive positions they had held for weeks. The German defensive line stretched across the Siegfried Line, concrete bunkers spaced every 200 yards, interlocking fields of fire covering every approach. American infantry had been dying against these positions since September. Artillery could hit individual bunkers, but German troops simply moved to adjacent positions and resumed fire. The problem was not hitting targets, it was hitting all targets simultaneously before defenders could react. Conventional artillery could not solve this. A standard American artillery battery consisted of 12 105mm howitzers. Coordinating a battery fire mission required 5 to 7 minutes, time for spotters to identify targets, calculate firing data, communicate coordinates, and execute the fire mission. A concentrated barrage on a 200-yard front required 3 batteries working in coordination, 15 to 20 minutes of preparation, and consumed approximately 300 rounds of ammunition. German defenders used this time. Forward observers spotted American artillery movements. Radio operators transmitted warnings. Infantry moved to reinforced positions. By the time shells arrived, German troops were under maximum cover, and American infantry still faced prepared positions with minimal suppression. The mathematics were brutal. To suppress a 200-yard defensive line required approximately 12 tons of high explosive delivered within 60 seconds. No existing American artillery system could achieve this. The engineering challenge seemed impossible. Deliver artillery battalion firepower from a single mobile platform that could move with advancing armor. American Ordnance Department engineers at Aberdeen Proving Ground began work in early 1943. The solution was unconventional. Instead of increasing gun caliber or adding more tubes to towed artillery, they proposed mounting rocket launchers directly on Sherman tank hulls. The weapon they designed was the T-34 Calliope, named after the steam-powered Circus organ with dozens of whistles. The launcher assembly consisted of 144 4.5-inch rocket tubes arranged in rows, mounted on a frame that attached to the turret of an M4A3 Sherman tank with 76mm gun. The entire launcher assembly weighed 3,200 pounds when loaded, added only 14 inches to the tank's height, and could traverse with the turret through 360 degrees. Each rocket tube was made from drawn steel tubing, 4.5 inches in diameter, 5 feet long. The tubes were arranged in 9 horizontal rows of 16 tubes each, creating a launcher array measuring approximately 6 feet wide by 4 feet tall. The entire assembly could be jettisoned in combat if the rocket launcher was damaged, allowing the Sherman to continue fighting with its main gun. The rockets themselves were M16 4.5-inch high explosive rockets, each weighing 38 pounds, carrying a 20-pound high explosive warhead with point detonating fuse. Maximum range was 4,600 yards, effective range was 3,800 yards. Muzzle velocity was 850 feet per second. Each rocket generated approximately 12,000 pounds of thrust during its 1.2-second burn time. Fire control was simple. The tank commander aimed the entire launcher assembly using the turret traverse mechanism. Elevation was set manually before loading using a hand crank that adjusted the launcher frame angle from 0 to 45 degrees. Once aimed, the commander fired the rockets using an electrical firing system that could ripple fire all 144 rockets in sequence over 90 seconds, or fire salvo loads of 36 rockets simultaneously. The electrical firing system was the critical innovation. Previous rocket artillery required manual ignition of each tube, limiting rate of fire and exposing crews to enemy fire. The Calliope system used waterproofed electrical wiring connecting each rocket igniter to a central firing panel inside the tank. The tank commander selected firing mode, single, ripple, or salvo, then pressed the firing button. Current flowed through the circuit, igniting rocket motors in programmed sequence. Production began in June 1944 at Pressed Steel Car Company in Pittsburgh, Pennsylvania. Initial production rate was 12 launchers per week. By December 1944, production reached 20 units per week. Total wartime production numbered approximately 800 launchers, allocated primarily to armored divisions operating in Northwest Europe. If you are enjoying this deep dive into American engineering, consider subscribing. It helps the channel and ensures you do not miss the next one. First combat employment occurred December 16, 1944, during German counteroffensive operations in the Ardennes. The 714th Tank Battalion deployed 6 Calliope-equipped Shermans against German positions near Elsenborn Ridge. At 0730 hours, the Calliopes fired their first combat salvo. 144 rockets launched in 90 seconds. Impact area measured 200 yards wide by 300 yards deep. Total explosive delivery was 7,200 pounds of high explosive, equivalent to 72 105mm artillery shells. German defensive positions across the entire impact zone were simultaneously hit. Bunker roofs caved in. Trench systems collapsed. Communication wires were severed. Forward observers were killed or stunned. German return fire was minimal. Wehrmacht after-action reports described the effect as overwhelming. Defenders could not identify firing positions, could not coordinate counter-battery fire, and could not maintain defensive positions under sustained rocket bombardment. American infantry advanced immediately after rocket impact, encountering disorganized resistance across previously impregnable defensive lines. The 714th Tank Battalion recorded results across 3 days of operations. 18 Calliope fire missions suppressed 27 German defensive positions. American infantry casualties during assaults dropped by 68% compared to attacks without rocket support. German prisoners reported that rocket attacks destroyed unit cohesion more effectively than conventional artillery because every position was hit simultaneously, eliminating any safe areas within the defensive zone. Comparative analysis proved American superiority. The German Nebelwerfer 41 rocket launcher was the Wehrmacht equivalent, a 6-tube system firing 320mm rockets. Each Nebelwerfer launcher fired 6 rockets with total weight of explosives approximately 210 pounds. Reloading required 5 minutes. A Nebelwerfer battery of 6 launchers firing simultaneously delivered 1,260 pounds of explosives, then required 5 minutes to reload. The Calliope delivered 7,200 pounds of explosives in 90 seconds from a single armored vehicle. A single Calliope equaled 6 Nebelwerfer launchers in firepower, required no reload time during the critical assault phase, and remained protected by Sherman armor during the entire engagement. German rocket artillery was effective but static and vulnerable. American rocket artillery was mobile, protected, and integrated with armor operations. British rocket artillery consisted of the land mattress, a 32-tube system mounted on trailers towed by trucks. The land mattress fired 3-inch rockets with total salvo weight of 640 pounds. Rate of fire was 32 rockets in 30 seconds. Reload time was 10 minutes. Range was approximately 7,500 yards. The Calliope delivered 11 times more explosive tonnage per salvo than the land mattress, did not require towed transport vulnerable to counter-battery fire, and could maneuver immediately after firing. British rocket artillery was effective for long-range harassing fire, but could not provide direct support to advancing armor. American rocket artillery moved with the tanks it supported. Statistical analysis from 1st United States Army operations in Germany showed consistent results. Calliope-equipped tank battalions reduced time to breach prepared defenses by 42% compared to battalions using conventional artillery support. Ammunition expenditure per objective captured dropped by 31%. Infantry casualties per kilometer of advance decreased by 54% in sectors where Calliopes provided direct fire support. The weapon's effectiveness created tactical innovation. Tank commanders developed new assault techniques. Instead of waiting for distant artillery to complete fire missions, armor formations advanced with integral rocket support. Calliopes fired suppressing salvos at maximum range. Shermans closed under rocket cover. Then Calliopes fired second salvos at close range immediately before infantry assault. The entire sequence took 8 minutes from initial rocket launch to infantry on objective, compared to 25 to 30 minutes for conventional artillery-supported attacks. German forces attempted to counter the system. Wehrmacht intelligence identified Calliope tanks as priority targets. Anti-tank guns received orders to engage rocket-equipped Shermans first. Luftwaffe pilots were briefed to attack distinctive launcher frames. None of these measures proved effective. The Calliope's armor protection and mobility made it no more vulnerable than standard Shermans, and the devastating effect of its firepower made destroying them a tactical necessity German forces could rarely achieve before the rockets launched. Post-war analysis validated the design. The United States Army maintained Calliope systems in service through 1948. The concept of tank-mounted rocket artillery influenced subsequent American weapons development, leading to the T-40 rocket launcher system in the 1950s and modern M270 multiple launch rocket system still in service today. The innovation was not simply mounting rockets on a tank, it was creating a mobile fire support platform that matched the tempo of armored operations. The Calliope solved what conventional artillery could not solve. It delivered battalion-level firepower from a single vehicle, suppressed entire defensive positions simultaneously, and eliminated the time gap between fire support and assault. German engineering never produced an equivalent. British systems remained towed and vulnerable. Only American engineers created armored rocket artillery that worked in the role armor needed: immediate, overwhelming, mobile fire support. December 1944, Hürtgen Forest. That strange Sherman with 144 tubes welded on top was not a joke. It was the solution to a problem every army faced, but only American engineers solved. The numbers prove it: 7,200 pounds of explosives in 90 seconds. The combat record confirms it. 54% reduction in casualties. The post-war adoption validates it. Every modern rocket artillery system traces its lineage to that unconventional weapon. American engineering was not luck. It was innovation under pressure, creating weapons that worked when it mattered most.